In this video, we're going to focus on the ASCII code. The ASCII code stands for the American Standard Code for Information Interchange. So in this problem, we are given a partial ASCII table. This is not the whole thing. And we're asked to convert the word blue to binary. So let's go ahead and do that. Let's make a table that will make this a lot easier for us. So we have the letter, the decimal value, and then the binary value that's going to correspond to that. So the first letter is going to be B, and then L, and then U, and then E. Now we need to pay attention to the capitalization. Capital B has a decimal value of 66. And then lowercase l has an ASCII decimal value of 108. And then U has a value of 117. And then E has a value of 101. So these are the letters that you'll find in a keyboard. Now the next thing that we need to do is convert the decimal values into binary values. Now the ASCII code is a 7-bit binary system. So 2 to the n minus 1, or 2 to the 7 minus 1, that's 2 to the 6, which is 64. 64 is going to be the highest placement for the binary numbers. So it's going to be 64, 32, 16, 8, 4, 2, and then 1. So to get 66, we need to add up 64 and 2. So we're going to put a 1 for those values. It's 1, 0, 0, 0, 0, 1, 0. So that is the binary equivalent of 66. So the letter B corresponds to the 7-bit binary code that we see here. Now let's move on to the next one. So the letter L has a decimal value of 108. To get 108, we need 64, we need 32, so that's 96. Now, if we add 16 to 96, that's going to be 112, which is too much. Since we don't need a 16, we're going to put a 0. Now, we do need an 8. So we have 96 plus 8, that's 104. We only need 4 more to get to 108. So we'll put a 1 on the 4 and a 0 for the 2 and 1. So that is the 7-bit binary code for the letter L. Now for U, which is 117, we need the 64, the 32, so that's 96. If we add 16 to 96, that'll give us 112. So we need 5 more. To get the 5, we need to use a 4 and a 1. So that is the binary equivalent of 117. If you add up 64, 32, okay, I'm not sure what just happened there. Sometimes this computer acts up. But if you add 64, 32, 16, 4, and 1, that'll give you 117. Now, for the letter E, we need to get 101. So we need to add up 64, 32, that's 96. So we only need 5 more to get to 101. So we're going to use the 4 and the 1. So that's the binary code for the letter E in the ASCII table. So thus we have this. The word blue has the binary codes 1, 0, 0, 0, 0, 1, 0, and then for L it's 1, 1, 0, 1, 1, 0, 0, and for U it's 1, 1, 1, 0, 1, 0, 1. And finally for E, 1100101. So that's how you could use the ASCII table that was given to you to convert a word into binary. Now, let's work backwards. So using the ASCII table shown below, convert the following binary coded message into a word. So feel free to pause the video and try this example problem. So first, let's get the decimal equivalent of each binary code. So this is going to be 64, 32, 16, 8, 4, 2, and 1. You know what? Let me write this better. I'm going to have to space out these values. So you won't get confused. So we have a 64, we have a 8, and we have a 4. So if we add those numbers, 64 plus 8 plus 4, this is 76. And 76, looking at the ASCII table, corresponds to the letter L. So that's the first one. So now let's move on to the second code. It's 1, 1, 0, 0, 1, 0, 1. So we have a 64, we have a 32, a 4, and a 1. So 64 plus 32 plus 4 plus 1, and that is 101. And 101 corresponds to the letter E. So we have a lowercase e. Now let's move on to the next one. So it's 1, 1, 0, 1, 1, 0, 1. So we have a 64, a 32, an 8, a 4, and a 1. 64 plus 32 plus 8 plus 4 plus 1. So that's going to add up to 109. And 109 corresponds to the letter M. So you can probably figure out what word this is going to. Now let's move on to the next one. So we got 1, 1, 0, 1, 1, 1, 1. So we have everything except 16. So it's 64 plus 32 plus 8 plus 4 plus 2 plus 1. And so that is 111. So 111, that's O. And now for the last one. 1, 1, 0, 1, 1, 1, 0. So we have everything except 16 and 1. So it's 64 plus 32 plus 8 plus 4 plus 2. And that is 110. And 110 is N. So the binary code corresponds to the word lemon. So now you know how to use the ASCII table. You know how to interconvert between the ASCII code and a binary code.